Hey, what's up, everybody? So I thought today take a break from the games and I would actually do a video about math, considering what everything that's happening in the world right now. I thought I'd just do a lesson. Now, again, this lesson isn't going to be like a super in-depth lesson. There's going to be some prior knowledge that's going to have to be known, right? But it's just something, right? I'm going to try and teach like little tips and tricks, things that'll make you solve some problems a little faster, kind of for testing, things like that. Just kind of speed your game. All right. And the first one I want to kind of tackle is parallel and perpendicular lines plus slopes. Okay. So it's like, cool, bro. Like, but what are they? What are parallel and perpendicular lines? Well, parallel and perpendicular lines, now they're just lines, just like anything, but we're categorizing. We're going more in depth. Like, what type of lines are they? Kind of like me. What am I? I'm a guy. Well, what kind of guy am I? Am I a skinny guy, tall guy, funny guy, angry guy, you know, big guy, bearded guy, dark guy, light guy? I'm categorizing. I'm just categorizing the lines. What type of line are you? A dotted line? Are you a parallel line? Are you a perpendicular line? What are you? Okay. So first thing we're going to go over is parallel lines. Parallel lines, definition: coplanar lines that do not intersect. Now, the two words that you might not know are coplanar and intersect. Coplanar means that you're on the same plane, right? You're on the same surface. So for example, if you're a student, you have a desk, right? And that top of that surface, that desk, the top area, that as long as they're on that, okay, then that's coplanar. Actual definition is a surface that it goes on forever, but we'll just go in a nutshell. It's two lines that are on the same. So for example, like these two lines, like a road, these are parallel. Why? They're on the same street and they never intersect. Or intersect in a nutshell means touch. They never touch. They don't cross. Cross is a better word for intersect. But yeah, they never touch each other. They never cross each other, right? If I have two things, like my hands, they're going two lines. Eventually they're going to touch. But if I'm going like this, they will never touch, right? So they would be like parallel to each other, right? Kind of important, right? Is ironic is planes, right? Planes in the sky. I mean, that's 3-dimensional. Coplanar or plane is 2-dimensional, meaning flat surface like a wall. But if I have to figure out a way that they're never going to touch, right? Planes, we don't want them, they'll crash, right? So here are some picture examples of parallel, right? These bookshelves, parallel, never touching. The railroad track, right? The tracks, never touching, right? Your lines on a piece of paper, never touching, right? The plug, never touching. Track, perfectly never touching. So they go on forever, never touch. They're on the same plane, same surface. Okay, that's parallel lines in a nutshell. Okay. Now, what about perpendicular lines? Well, these are the perpendicular ones. Those a little more interesting, I guess you can say. It's a little more complex. So, perpendicular lines are when two lines intersect. They do cross each other. They do touch. But what's special about them, because we could have two lines that cross, but what's special about them is that they make a 90-degree angle. And a 90-degree angle is this little square right here. That's what shows 90 degrees, right? If I have two lines that cross, I have a 90-degree angle, right? There's some prior knowledge there of 90 degrees. What is 90 degrees? It's a right angle, okay? And you see these in real life. Window panes always have that cross. Foursquare, if you played this back in the day, right? They have 90 degrees right there. These two lines right there are perpendicular to each other. Your floor tiles, look. So if you're at home right now, take a look. See if you could find any more perpendicular lines, right, around your house. They're everywhere, right? And they make a perfect 90-degree angle, right? 90 degrees. Right here, they cross 90 degrees. Now the problem is some people, right, you use your eyes and you look at something, you're like, that's parallel. Or, oh yeah, those are perpendicular. But how do I know for sure, right? In order to do that, we got to do some surgery, meaning not literally, not Grey's Anatomy, right? We're not gonna go that deep. What we're gonna do is Surgery meaning we're going to dive deeper. Now we're going to look more mathematical, not just our eyes, not just like what are they. We're going to actually like solve them and figure it out, dissect it, right? Get into the meat of it. So let's do some surgery. Surgery is, how do I solve it mathematically? You might be like, right? Like what? Everybody's favorite part, the math. But it's not hard, right? I'm going to show you an easy way that you're gonna do these, you're gonna knock them out, right? So how can you tell if something's parallel or perpendicular 100%, right? How do you know, right? Not just with your eyes, like, oh, those look like they make, but what if it makes on a right angle? What if it's 89.9 degrees, 89.99 degrees? If that's it, then eventually they're not gonna be parallel. Oh, they look parallel, they're not touching. Yeah, but what if they're gonna touch like way later, like way later, far down the line, right? If they ever do touch, they're not parallel. They can never touch. Okay, so in order to do that, we're gonna have to know slopes. And slopes is something that you learn when you're, I'd say 6th grade, 7th grade ish, right? You learn the whole rise over run. I'm not gonna go into it, but your teacher might have gone over how do you find the slope of a line? Well, the corner plane count up, rise over run. And if your line is going up, you have a positive slope. If your line is going down, you have a negative slope. If your line is flat, well, then you don't have a slope because you're walking perfectly flat, right? And vertical, if you have something that's perfectly up and down, it's undefined. You don't have a slope because you're perfectly straight. There is no slope. There is no up or down. There is no, here you're flat. You still can walk on it. Can you walk up vertical? No, unless you're Spider-Man or you have special shoes, right? So that's what a slope is in a nutshell. Why is it important? Because that's how we're going to solve if lines are parallel and perpendicular mathematically. Now, lines, they come in equations, and I'm sure you've seen them plenty of times. The one we're going to look at right now, we're going to look at it where the basic way, right? In a nutshell way. And we're going to look at slope-intercept form. Slope-intercept form is the equation of a line. So for example, we have the y equals mx plus b, y equals 2x plus 3, and it shows you, right? It's just an example. Problem is I don't care about the y-intercept. Bye. Later. Bye, Felicia. All right? Bye. I don't care about that. All I care about is the slope. That's all I need in order to know if lines are parallel or perpendicular. Okay? And here's where parallel lines always have the exact same slope. Notice that I capitalize this, all right? It's a big deal. Exact same means the exact same. No different, no change, nothing different. They look exactly the same, all right? They are the exact same number. Perpendicular is where it gets tricky. Exact opposite slope. Now, exact opposite, that's the one I'm going to have to go more in depth in. Okay, parallel lines. So, for example, if I have an equation, y equals 2x plus 7. I have another equation, y equals 2x plus 3. I don't care about this part. I don't care about the y-intercept. I don't care about the variable. All I care about are the slopes. Notice I have a 2 and I have a 2. They're both positive 2s. Are they the exact same? Yes, they are. So they are what? They're parallel. Those are parallel lines. Those are the equations of parallel lines. Okay? And those equations, what you're used to doing is graphing them. But how we're doing it, we're solving it without graphing. Way faster for now. Okay? Perpendicular, that's where it gets tricky. So I'm going to take the very first one, the y equals 2, right? If I want a perpendicular one, what would the slope have to be? The exact opposite. Well, here's the thing. I'm going to do a checklist. First, I'm going to look at the sign. We said that this was a positive 2. Okay, great. So the exact opposite of positive is negative. So I know that my perpendicular one is going to have to be negative. Okay, I'm going to change it to a different color. Negative. Now, the exact opposite of 2. What's the opposite of 2? It gets tricky. Well, I'm going to write the 2 here. But the opposite, right, is, well, what do I do with that? Well, there's an imaginary 1 on the denominator for the 2. So the exact opposite of 2 or 1 is I have to flip these. The numerator becomes the denominator becomes the numerator, or in a nutshell, the top becomes the bottom becomes the top. All right. So for perpendicular lines, I have the negative and I flip them 1/2. That would be the perpendicular line, the equation of the perpendicular line that's opposite that one. They make the perfect cross without having to graph it because I know it. I know the rule. Okay. It's just faster. And you're going to see it. We're going to practice it. Let's take a look. All right. That's tricky part. And I put this slide in so that you guys can see another way of perfect opposite, right? Because you're like, what exactly does that mean if you're not sure? I give another example right here for perpendicular. And what it is it shows right here. I have 2/3. Exact opposite. Remember, top becomes the bottom becomes the top. 3/2. Ooh, it's a positive. I change it to a negative. -3/2. And look there it is. It's just another slide to explain, just in case you need a little bit more detail. Let's practice it though. All right. Yes, we're going to practice. I know a lot of people are probably going to be like, practice? Talking about practice? Yes, you got to practice just like anything, right? If you don't practice, you're not going to get it. A lot of people are like, they do one problem. They're like, oh, don't get it. I suck at math. And it's like, no, bro, like you're all right. It's just, you got to do another one and do another one. Like, yeah, but that person got it after 2. Well, that person maybe is just a little more talented, right? There's nothing wrong with that. It's fine. I mean, in football, in sports and anything, there's some people that get it real quick and some people that have to put in the work to get it, right? There's nothing wrong. You just have to be willing to put in the work. And a lot of people forget about that. So in your mind, you have to realize, like, no, just keep trying. Ask questions. Don't just say you can't, right? I get this part. I don't understand that part. Teachers will appreciate it much more. Trust me. The worst thing you can do is go to your teacher and be like, I don't get anything. It's like, no. Okay, you get to here, good. What don't you get right here? Tell me. Okay, I can explain that. All right? Trust me. Just put in that practice. Okay? Practice problem number 1. Are they? I shouldn't put they. It should be like, are these lines, are the equations of these lines, which are they parallel, perpendicular, or neither? Well, go by a rule, right? They're in slope-intercept form. They're in that, what I mean by that, they're in that y equals mx plus b. And all we care about is the m. That's the slope. Bye-bye. Don't care. Don't care about this, okay? So, parallel means exactly the same. So all I got to look at, that number. Notice I kept the negative in there. That's part of it, okay? Don't ignore that. That's part of the slope, okay? It tells me if it's downhill or uphill. The 4, it's positive, so that line's gonna be going up and down. The bottom one, the -1/4, that's a line that's gonna be going downhill, okay? So parallel, exact same. Well, I have a +4 here. I have a +4 right here. Right here, what do I got? I got a -4. These are not the exact same. Therefore, they're not parallel. Biparallel. You're not parallel. These lines, the equation of these lines, when you graph them, they're not going to be parallel. They're going to end up touching each other. The question is, when they cross, are they going to be perpendicular, meaning a perfect cross with the right angle? Well, let's check. Perpendicular, exact opposite. Let's pick one. I'm going to pick the -1/4 because it's in the form that we like, right? So -1/4. If I want the opposite, okay, that's going to equal a positive, right? I'm going to flip these. 4/1. Okay, 4/1. Remember, it's an imaginary one that makes it a 4. What do we got there? Let's go. They are the exact opposite, right? We just figured out. We solved it. We checked it. They're the exact opposite. So these two lines are perpendicular. Practice problem number 2. Are the lines parallel, perpendicular? Neither, right? We could have two lines that end up crossing each other, but they're not perpendicular. So they're nothing. So let's check. All right. Again, we have it in slope-intercept form. Y equals mx plus b. I don't care about this. Don't care. All I need are the slopes. So slope is 5. Slope is -5. Are they the exact same? Same sign. Positive, negative, exact same. I have a +5. I have a -5. They are not the exact same. They're close. They are both 5s. Some of you might be like, hey, but they're 5s. Yeah. Not the exact same. They're a little different. Okay, so they're not parallel. Perpendicular. Perpendicular. Well, I'm going to take that 5. I'm going to put it over 1. Remember, I went over that. Over 1, right? That any whole number is technically over 1. Okay? If I flip it, the exact opposite would be 1/5 and a negative. Right here, I do have a -5, but is it -1/5? This is what I need for it to be perpendicular. That is not what I have. So it is not perpendicular. The answer is neither. So a lot of you are going to be like what? And it's just that they're lines. They're just not parallel and perpendicular lines. I'm a guy, but like maybe I'm not the funny guy, you know? I'm not. These are lines, but they're just not the parallel and perpendicular lines. They don't fit that criteria. Okay? Next one, practice problem number 3 is, again, same thing. We're going to solve, are these lines parallel, perpendicular, or neither? All right, well, let's take a look. Again, they're in y equals mx plus b. Don't care about this, right? We don't care about the y-intercept right now. That's for a different day, or it's not relevant for right now. All I care about is the slope. Parallel lines have the exact same slope. Now, if I take a look at these, right, are they the exact same? -6 and -6. That's the same. So what are they? They are parallel lines. There are two lines that are never going to touch each other. Not bad. Now, last problem. Practice multiple choice test problem number 4. Practice problem number 4. Now, the reason I have this one in here is because these type of problems come out in tests pretty often. Now, not all of them, right? There's harder ones, easier ones, etc. But this is one that does, usually I see it once in a blue moon. You'll see it, not once in a blue moon, but you see it pretty often. And a lot of people, the difference is that they put it on there to see if you just know the basic part of what parallel and perpendicular line are. And a lot of times people, what they do is they don't know that part. They know like, oh, I have to graph it. I'm going to graph every single one of these problems. I'm going to graph it and check which one crosses. And it's like, that'll take forever. And you might get the right answer, but now you've wasted valuable quality time that you could have put into other problems. And then you finish the test and you're like, hey, I was doing it right, but I didn't have enough time. And it's like, you did, because when they make the test, they do it that like they think you're going to be doing the optimized, the fastest way. And sometimes you choose not the fastest way and you still get it right, but that problem should have taken 1 minute versus 5 minutes. And that's just the way it is. I remember I worked in a store, and when we had to change mannequins, move the clothes, I found out that, you know, when they said move these shirts to this shelf, right, that should take like 5 minutes or less, but let's say 5 minutes. They put 5, and it would take us 15 because our store has customers, they mess things up, you have to fix, etc. I didn't know they had a practice store that was set up always perfectly. And so when they did it and they would send us the information, well, they have a perfect store, right? They just picked it up, they would get up, walk, and then put it, and it's all easy. No, right? They think that it's perfect. Our store's not perfect, right? So we want you to do it the fastest way. Here's the problem. Which equation is perpendicular to y equals 1/2 x minus 1? Now notice we're lucky. It's in y equals mx plus b. I don't care about this. I don't care about the y-intercept. All I care about is my slope. 1/2. Okay, so I'm going to write my slope right here. 1/2. Okay, so perpendicular. Remember, parallel, exactly the same. I'm asking for parallel. Which one is exactly the same? This one. We don't need that one then. 1/2. That one's gone. I already know. Okay. Perpendicular means opposite sign. We have a positive, so my answer has to have what? Opposite. is negative. Does this one have a negative? No. Bye-bye. This one does have a negative. This one does have a negative. So these two are left. All right. Now, opposite, I have to flip. The next step, flip. Numerator becomes the denominator. Denominator becomes the numerator. So let's flip these bad boys. 2 over 1. And 2 over 1 equals, remember, 2 divided by 1, or 2 over 1 is the same as 2. So which one has that? Wait, but I have the 2. Oh, don't forget the negative, that opposite sign. Bye-bye. My answer is C. And I'm done. Now, again, your thought process might be different. You might just flip it in your head. Some of you might be like, I don't have to write all that. Great. Fantastic. You're a star. Right? But practice it. Sometimes you'll forget. It's good to write the details. I almost forgot the negative there, right? Almost forgot. And I was like, wait, what? So process of elimination there, just by knowing little things, remembering little things. Even if you didn't remember everything, at least if you remember some of it, I was able to knock out 2 and you have a 50-50 chance, right? And now I didn't have to graph. I didn't have to graph anything. I didn't have to check anything. You're done. Okay? Now it's time, like, are you ready? You should be ready. You should be ready to just do parallel and perpendicular lines when they're in slope-intercept form. You should be able to identify them, right? Very easy, very to the point. Hope you like the lesson.